Hello! Today let us look at some of the basics of Python. In Python, variables are defined just by defining a variable name followed by the kind of variable type. So for example, if I define x is equal to 2.0, then it will automatically be realized as if it is a floating point number because of this decimal point here. If it is an integer, you can simply say something like a number without a decimal point. And if you want to define a string, you can define it like so, with quotes, double quotes or single quotes surrounding the string. So this will be a string. To define collection of data, we can use a list. In case of we want to define a list, we can simply define it by surrounding it by this square brackets. So a list can consist of multiple data types. So I can have, say for example, an integer, a floating point number, a string, and also I can add variables within this square brackets, and they'll be all a part of this list. To access a particular item in the list, we can use the corresponding index. The indexing in Python starts with 0, like same way in which you might be used to using in C or C++ or Java. So it starts with 0. So this particular element here is at index 0, this is at 1, this is at 2, and so on. So if I want to say access this particular element x, then I can use the index 0, 1, 2 and 3. So my list 3 will be pointing to x, which is basically 2. So let me print this value out to see that indeed we are pointing to this particular element. So if I print it out, you can see that the value is 2. One more important thing which we can do in lists is the slicing, which is pretty much important in accessing a subset of the list. The way this works is you have to provide a starting index and the index which is one more than the ending index. What I mean to say is, if I want to access, say, this second element and the third element, then I can give the index of this element which is 0 and 1. So I can do something like so 1, and then I can give the ending index, but I have to use a colon which defines that I want to do the slicing operation. So the ending index here, I want to include this, so I'll give the ending index of this element. So it's going to be 0, 1, 2 and 3. So I want to start at 1, that is I want to start here, and I want to end at 1 less than this element. So 0, 1, 2 and 3. So I want to stop at 2. So let me print this out and see what I get. Basically we should now get 2 and string. So there we have these two elements extracted out of this particular list. If you want to go up to the end, then we need not give the last element, and then it will go up to the end. So starting at the first index and going up to the last index. So Z here is this last element, that is, this is a string. Or else we can also define, we may not define this first index. In that case it will start right at the beginning. So if I do something like print my list, and if I start by giving a colon, then it will start from the first index and then it will go up to whatever is given here. So let me again give 3. So 0, 1, 2 and 3. So it will stop at this string, but it will start from 1 now. So I have 1, 2 and string, that is this 3 elements. Oops. Okay, so this 3 elements. Okay, that's more or less about list. Let us now go to tuples. A tuple is very much like a list, but it is immutable. That is, you cannot change the elements inside the tuple. So if I define a tuple something like this, so the tuple is defined by using this parenthesis. So I can define a combination of all type of elements. So let us start with a string, then let us have say one more string, then let us have a integer, then let us have a floating point number, and so on. So if I look at this tuple, so you can see that these all elements are grouped together. We can however not change any part of a tuple. So if I try to say change this element to something else, let us say I want it to be 2, then it will give an error because tuple does not support item assignment. So you cannot change an element inside a tuple because it is immutable. However, you can extend it by adding some extra elements to it. So I can say the previous tuple, I want to add say one more element to it, and let me say it's equal to 5. So I can add elements to it. I can also add multiple elements, so I can add say 5 and 3.6. So now let me put this print after the change. So now you can see that 5 and 3.6 has been added to this existing tuple. Oh, you can do the same thing with list as well. You can add elements to a list by simply adding it something like this, and you can add additional elements within this square brackets. So say I can add another string, and I can add say 8.657 whatever. So I have appended this. Now let me try printing this list. So this is the latest list now. So if I print this, it should be somewhere here, yeah. So you can see that these two elements have been added to the existing list. Okay, yeah, that is, if you want to add one single element, you can use the append function in the list. So you can use say append, and you can add a single element to it. So let me add this one more string, and I'll just cut and paste this print statement just after doing the append, and it's not been appended. No, that is, yeah, it has been actually. Oh, sorry. So this is the one which we should be looking at. I was actually looking at this. Okay, so this is the this has been appended at the end of this list. Okay, that's more or less about the list and tuple. Let us move on to the another type of collection of data type, that is a dictionary. Dictionary is very important in our case when we want to save some kind of parameters and associated values to those parameters. So a dictionary is basically a key value pair. So the way we define a dictionary is by using this curly brackets, and within this curly brackets we define two values separated by a comma. So what I mean to say is I will have a key, so let me say a key, and then an associated value to that key. So let us say the first key, my key, is saving a value 2. Let us define one more key. The key can be of any type, but we will be using strings. So a string can be defined either by double quotes or single quotes. So you are free to choose whatever you want. You can use single quotes or you can use double quotes. Let me use double quotes here. Sorry, let me use double quotes here. Let me define one more key. So let me say key 2. Its value, let us say, is equal to say 5. Let me define one more key and define its value as say 100.98. okay, and we can obviously print this out, and we have this. Remember that the order is not maintained, so your order of definition may not be the order in which it is actually saved inside this dictionary, so you should not rely on this sequence here. You should, however, use the key to access the value. So if I want to access a particular value, let us say I want to access key 2, so I can just pass the key value, key to this index, key as an index, and it will return the value associated with it. So if I print myDict key 2, then it will print 5 because the value associated with key 2 is 5. Okay, if you want to add an additional value to the dictionary, then we can do so by, let me put this print later. So we can do so by just passing that particular key some, let me say, new key. Well, it may not, it can also have spaces and whatever you want to. Okay, you can have this new key and you can assign a value to it. Let me say new key is the value associated with, I can say, is 5000.456 or whatever. So now this particular additional key has been added to my dictionary, and when I print this, you will see that the new key has been also added to this dictionary. Okay, you can obviously change existing values of the key. So for example, I can do something like, say I want to change the value of associated with key 2, so I can do something like key 2 and I can change its value. So now I don't want it to be 5, but I want it to be, say, 65.7. so I can obviously do that, and you can see that it does not print it because I have to do the printing after changing the value. So now you can see that key 2 has a new value of 65.7. okay, I guess most of the things have been covered now. So let us look at control statements. Let us start with if. So to define a if, you use the if keyword followed by a condition. So let us say, let us use some variable, say x, which is equal to 2. So if x is, say, less than 3, then we do something. Let us say print something like x is less than 3, and obviously this will evaluate to true because we know that x is equal to 2 and 2 is less than 3. So this particular statement will be printed. So we can see that x is less than 3 is printed. On the other hand, if we had said something like x is greater than 3, then it will evaluate to false, and therefore this particular statement is not printed. We can use other statements for comparison, like double equal to, which sees whether x is exactly equal to 3. So if I say x is equal to 2, then this will evaluate to true, and let me change this now. So this will be printed because we know that x is equal to 2. X, we can also use something like less than equal to, or greater than equal to, or not equal to. We can also use something like for example, x is equal, let us use something like this. This is something like taking the full statement, and we can do a not operation over that full statement. So this is a complicated way of writing x is equal to 2. So I'm first of all saying whether x is not equal to 2, and then I'm saying if whatever is the result of this evaluation, so whatever is the result of this evaluation, if it is not true, then this statement will be printed. Well, a very convoluted way of saying the same thing. So obviously this will be printed in this case because x is equal to 2. We can combine statements, like for example we can say x is not equal to 2. Let us say now x is equal to 2, and say y is equal to 8. So and y is equal to 8. Then we can print something like print x is equal to 2 and also y is equal to 8. So let's print this out, and obviously it's printed. So any one of this, if it's not true, then we will have this will not be printed. So for example, if I can say x is not equal to 8, then this will not be printed because one of the condition is false. Similarly, we can use OR. So if x is equal to 2, we need not have this parenthesis here now. So if x is equal to 2 or x is not equal to 8, then this will be printed. So obviously this will be printed because this is evaluated to be true. Again, it is very similar to other programming languages. Like for example, if we use a OR, then if this statement is evaluated to be true, then this statement will not be checked at all. On the other hand, if it is AND and this one turns out to be false, then this statement will not be evaluated at all, because the result of the full statement can be automatically deduced out of it. Okay, let us look at else if. We can also say something like else if x, let us use another thing, z is equal to whatever that string was, and let us make this AND so that this evaluates to be false. And okay, so if x is equal to 2 and x is not equal to 8, then this will be printed. In this case it won't be printed, we know, because x is equal to 8 and we are checking if x is not equal to 8, so this will not be evaluated. So let me change this. Anyways, so else if, so our control will be coming up to this point. Else if z is equal to this is a string, then let us print something like we are here now. Okay, so let us print this out and we will see that we are here now is printed because z is actually equal to this particular string. We can have multiple statements within a block by just having them aligned or having them indented by the same amount. So we can print one more statement here, say this is also under if statement. Then let me do a similar thing under the if else statement as well, else if statement as well, and that's it. Let me print this out, and you can see that both these statements get printed because this particular condition evaluates to be true. Okay, let me put this on top. Alright, so let us look at the else statement now. Now we can have else, if else, and finally we'll have a else statement which will be actually associated with this if. So finally, if both of this evaluate to be false, so let me make this not equal to, and let me print a statement here. Finally, I have reached here. So it prints finally I have reached here because both these conditions evaluate to be false. Okay. Fine. Let us now look at while loops. So yeah, one more thing. The way in which a block is defined in Python is very standard. It starts with a colon and it ends wherever the indentation ends. So the block, this particular if block, ends at this point basically because I have stopped indenting this code, and it starts at this colon. The same thing goes for while as well. So I can define while some condition. So let us define a variable here, say I equal to starting with say 0 while I is less than say 10, okay, colon, and I'll print I and I'll increment I every time. Oh, I plus plus doesn't work here, so I'll have to do something like I plus equal to 1, and it prints 0 through 9. Well, this is a very simple thing. It every time checks whether I is less than 10, and if it is not, if this condition is satisfied, then it will go into this loop, and if it is not, then it will break out of this loop. Let us look at a for loop. A for loop is mostly defined by using the range function. So the way it is defined is something like for say j in range say 10. Now let me change this to say 8 because we used similar thing in while, so up to 8. Then print j. Well, this loop is going to go from 0 through 7, not 8. Remember that. So well, it started from here and it went up to. So let me put one more print statement here. And let me put a new line, so it will put two separate lines in between these two lines. So it has printed from 0 through 7. Okay, now let us look a brief about this range statement, range function, sorry. So this range function is the one which returns a list of elements. So range basically returns a list of elements. So when I passed 8 to it, it returned this particular list of elements from 0 through 7, and that is why these numbers from 0 through 7 were printed. So basically a for loop assigns j to be a value of this range, this list, whichever is returned by range, one element at a time. So if I do say 10, then it will return elements from 0 through 9. You can change the behavior by passing extra arguments to range. So if I type say for example 5, 10, then it will return, this range function will return values between 5 and 9. Also I can give a different increment other than 1. So if I give an increment of 2, then it will start with from 5, then it will jump to 7, then it will jump to 9. Okay, I think this is clear. So let us look at functions now. A function is defined by using the def keyword. So you define a function. Let us define a simple function called sum, which actually let us not define sum, because sum is something which is already existing, and well, you can define, but let us define something like my sum, so which takes in two values. So let us say x1 and x2, and it returns the summation of these two values. So this is how you define a function. You can have obviously more statements within this. So let me say sum is equal to okay, well, I can use that, but just to be more cautious, so x1 plus x2, and let me return my sum here. And yeah, this function is defined. We have not used it though, so I can print my sum. Let me pass in two values to it. So let us say 10 and 105.98. Remember, we never defined the type of x1 and x2. Now depending on the value which is passed to it, so depending on that, it will be decided at the runtime how this evaluation has to be done. So now it is a floating point number which is written. However, if I say don't put a decimal point over there, it will be a integer. Also, I can have a string, like say for example, let's learn to, and let's learn to program. And if I pass these two arguments to my sum, then it will combine these two as if it is a string. So you need not define separate function types. So depending on what is passed to it, automatically it will be decided at the runtime. However, this can also cause problems. So for example, if I do something like let's learn to, and I pass integer here, then it will cause a problem, because I cannot add a string to an integer just like that. Okay. So that's more or less about functions. Let us look at how do we define classes. So to define a class, we just use the class keyword, then define the name of the class. So let us define a point class, and that's it. Then we define this is the start of the class. The constructor is defined by using two underscores followed by init, followed by another two underscores, followed by opening and closing parenthesis. So you define, so you pass a variable called self. Well, we don't pass it explicitly. It is automatically passed by the Python runtime. Then you define this function. Yeah, obviously we are defining a function, so we have to use the def keyword, and then we define whatever is to be done by this constructor. Let us pass two arguments to this point constructor, x and y, and within this let us define two variables. Let us say self.x is equal to whatever is passed, and self.y to whatever is passed, and that's it. Our class is defined. Okay, let's look at this in a little bit more detail. The first argument that is passed to any method within a function, within a class, so any method which is defined within a class, the first argument is always self. That is the reference to this object whichever is being created. then followed by the list of arguments that you want to pass to this particular method. Now let us define more methods. Let us define one more method called get say xy, which will simply return the coordinates as a tuple. So let me return this, and let me return it as a tuple, and I will return the x coordinate and the y coordinate of this point. Okay, so this is how you define a class. To define an object, let us define now an object of class point. So to do that, you simply, let us say p is equal to point, and you remember the constructor takes two arguments x and y. So let us define the two arguments here, and let us then use this get xy and print the values out. So oops, I want to do it here. Print, and let me say p dot get xy, and this should print actually the tuple which is returned by this get xy. So this is one point. We can define one more point. Let us say p1 equal to point say 5.0 multiplied by 3. I'm sorry, 5.0 and 3. So let me print this out. So p1 dot get xy. Now this should print 5,3. Okay. Well, these are most of the basics which I wanted to cover in this short video. Okay, in this case you might have realized that the second argument is an integer, and you may not want this to happen. So in such a case, it is always good to typecast it, and to do so I can simply wrap this particular variable by using the type in which I want to convert it to. So now you can see that it is a floating point number. Okay, and you can do similar typecasting by using things like int or string, and so on and so forth. Okay, so that's it I want to cover in this video, and in the next video I'll be talking about something about accessing files and reading parameters from files and so on. So see you in the next video. Until then, bye bye.